So, alchemy, and you guys don't have to take all this down. What I really would like if you guys take this second bullet here. Alchemy was the precursor of chemistry. It was what people studied and that eventually evolved into chemistry. And you can see the word chem is in there, alchemy. So that's what the people in the Middle Ages believed in. What the whole idea about this was that you could take something very cheap and make gold out of it. So it was kind of more like magic. It was more like Harry Potter kind of stuff, you know. But we're just, us chemists, we're just regular old muggles. So we don't do any of the magic stuff. So we're going to talk more about that as we move. So this alchemy was kind of like chemistry, kind of like magic. Not really true science. You guys don't have to take this down, but they did use symbols for substances, similar to how we use symbols for substances, which you guys can see in the periodic table. They had symbols for gold, copper, yada, yada, yada. And what they believed is that you could transmutate, meaning change one thing to another. You can change substances. So, like I said before, the goal was to turn it into gold. Gold was the goal. In real chemistry, we can't do that. If we could, well, then we would. But it's a little more complicated than that, and we're going to learn more about that. Some things that alchemists did, though, they discovered certain elements. Mercury, sulfur, antimony. And they also studied some properties of those elements. Sure, I'll write this down. It's important. Also, they developed certain lab apparatuses, or apparati, procedures and some experimental techniques that we still use today. An apparatus is basically a thing that does something in chemistry. It's just some things that you put together in order to do something. And we're going to be using all sorts of apparati as we move on the year. They learned how to prepare simple acids. We made some alloys. Anybody know when I say alloy what that means? Rami? Yeah, exactly. Good. An alloy is just when you mix up two metals together. Keep that in mind for later. That's a hint. And they developed some of the glassware, similar to stuff that we use today. So moving forward, you guys don't have to take this down. This is just a summative slide. The root of chemistry, alchemist has the root of the word chemistry in it. See, I underlined it, chemist. So that's where actually chemistry was derived. So, moving forward, and you guys don't have to copy this down, but here's what we're going to do. We're going to try to make gold. Let me guys ask you a question. You look at a penny. Julio, can you keep your head up, please? A penny. What color is a penny? What color, Jason? It's not quite bronze. What? I'd say it's like a brownish, reddish, orange color. Right? So, anybody know what material a penny is made of? Copper. Not all of them. What were you going to say there?
I don't know what year it is, the fact that I know it's sad, but after a certain year, they stopped making them out of copper.
It's true.
Okay.
After, in 1982, the price of copper was in fact more than a penny was worth. So, and it actually, right now, it still costs more money to make a penny than a penny's worth, interesting enough. So what the U.S. government did in the U.S. Mint, they made a penny out of zinc. So most of a penny, like a penny made after 1982, is 95% zinc, and it's only clad in copper, meaning coated in copper. So if you can imagine the outside of this at a molecular level, because that's what we're trying to do. We're trying to get this penny we're trying to imagine what happens to the particles. So imagine just a bunch of really tiny, like reddish-brown atoms. And that's what copper. So Mr. Costa, I think, is going to start our little demonstration, and we will come back to this. All right. So in the penny experiment that we just did, let's sum it up. We demonstrated a couple of, let's think about what happened on the molecular level to the particles. So what happened to the zinc? Where did the zinc move to? I think Dominic said it. What did you say? Can you repeat that?
I said it went and attached to the copper.
Yep. So we had zinc. There was a chemical reaction. So we took zinc and we put it into the solution. And then zinc in that solution reacted to form zinc metal on the copper. So essentially all we really did, we did a couple different chemical reactions, which I'm really not going to get into the actual aspects of it just yet. But we took zinc and we converted it to zinc somewhere else. So that's what we did there. Okay? So that's what we did, and what we're going to do now is we are going to look at a molecular model. We're going to model what happened to those atoms and those particles at a very small level, and we'll use that to explain what we see for our observations. So let's move on. So we just talked about this. Did we really turn silver into gold? Copper into silver and then silver to gold? No. We think this is unlikely because, well, that would be too easy to make gold, and gold's expensive. Things that are easy to make are cheap, like aluminum is now. Before aluminum metal, they never find in nature. It's very rare. I shouldn't say never. But what happened was chemists basically took this type of rock, they call it an ore. Who took earth science here? Raise your hand. Who took earth science? I took earth science. Oh, great. So you guys talked about ores in there. They basically took an ore and they did a process called reduction. They reduced the ore into metal. And they got the metal out of it. And that was one of the contributions. I actually have a slide that I'll show you guys in a little bit. So it's unlikely that we actually made gold. But let's take a look at this molecular model. Let's say these orange particles represent the copper. I used that because their copper's orange. So what we did was we heated it with sodium hydroxide and zinc, and we coated it. It's actually a process similar to what we call electroplating. Electroplating, anybody ever buy gold-coated jewelry or gold-clad jewelry?
It's stuff that turns your fingers green.
Yeah, it's cheaper than all gold, but it's clad. It's similar to what we did here. They take gold in a solution and then they plate it on a cheaper metal. So what you see on the outside is gold, but really it's not all gold. It's just coated in gold, gold coated or gold clad. Then what we did. So that's what this molecular model represents right here. It represents our copper coated in zinc. So on the outside, we see the silvery zinc color. And that's why it looks like that color. Then what we did, what do you think heating things up does? Heating things up, that just kind of mixes up the particles. So if you guys could imagine on a molecular level what's happening to the atoms, this is going to be something we're going to be doing a lot of, molecular modeling, using our observations to figure out what happens to those atoms. What happens is, if you can imagine that if we mixed up those silver and orange particles, what color would that look like from our view, far, far away from a big scale? Looks like it's gold. So that's why it appears like that. It reflects like it's gold. So